Hi everyone, welcome to Vedantu JEE English. I'm Diksha, your chemistry master teacher. So everybody do let me know in the comment section if I'm clearly visible and audible to all of you or not. Right? So happy Independence Day to everyone out there, right? And this is a very special day, and for this special day, on Vedantu also something really big is going on, right? That is first thing is on MVSAT program, MVSAT scholarship program, where registration is completely free, right? You just have to register yourself, give the exam online or offline. Preferable is offline, and offline test dates are these: 4th, 5th, 11th, and 12th of October. That is your offline test dates, right? Now, if you see, ma'am, what is the benefit of giving MBSAT program? Right? You will get up to 100% scholarship, right? Gifts like iPhone, iPad, all these things will be available to you. So all these things are there in the MBSAT scholarship program. Okay, right? And if you see, I'll just tell you that how you can enroll yourself, because these are the things that you will get, right? Oh, wait a minute. Okay. So if you see this over here, this is the description box, and here this link. Can you see MVSAT register now? Click on this and you will land up to this portal where you just have to register yourself, right? You just have to register yourself here and click on proceed, and you will be enrolled to the MVSAT scholarship program, right? And one more thing, that our freedom sale is going on for Independence Day, right? Freedom sale is going on for Independence Day, that you will see over here, right? Up to 79% off we are giving you. Sigma batch is only at 1499, right? So that kind of sale is going on, and this sale will end on 17th of August. 2 days left. Okay, so you can decide, right, what you want to, get enrolled into, and according to that, take advantage of this sale, right? Okay, yes, everyone. So now let us start the session. If you see, let me also see your comments over here, what you guys are saying. Portion for gate 12. Yes, beta, this is no, in the scholarship program, right? General questions will be asked to test that how much efficiency you have, not difficult questions, easy, doable questions. And if you're talking about Sigma batch, in Sigma batch 11th class 12, whatever is there in JEE Mains and Advanced, that will be covered. Okay. Okay. Now, shall I start? Yes, everybody ready? Ready for the class? See, yesterday we talked about coordination. We talked about that we have three salts, simple salts, we have double salts, we have coordination complexes. Then we started understanding what exactly are these coordination compounds. I told you about ligand. I told you about classification of ligand and central metal atom. Now we are going to focus on rest of the things for your coordination chapter. So guys, today we are going to talk about the nomenclature, right? Just give me a second and I'll just put my specs, because it becomes very, very heavy on the eyes otherwise, right? Now, next thing is we discussed about classification of ligands also, chelate ligand, ambident ligand, all these things we already discussed, right? Let's understand what we are going to do today is nomenclature, formula making, how to write the formulas of coordination complexes, and Werner's theory, right? So this is also a major part, because if you don't know how to name the coordination compounds, the full chapter, because you don't know if they have given the name, you have to draw the formula, or they have given the formula, you have to write the name. If that thing is not you're able to understand, then throughout the chapter you will find it difficult to understand things, right? So first is coordination number, right? Coordination number is number of donating sites, donating sites linked to central metal atom. That means if I say that you have CONH3 6. Now we know that each ammonia, because ammonia is monodentate, one ammonia has one donating site, 6 ammonia will have 6 donating sites. So we'll say coordination number is going to be 6 here, right? Ammonia is monodentate. It has only one coordination site. It has only one donation site. But if you talk about this cobalt, it is linked to 6 ammonias. That means cobalt is having 6 donating sites. So answer is going to be coordination number is 6. The definition is coordination number of a metal ionic complex can be defined as number of ligand donor atoms, right? We are not saying that how many ligands are attached. Usually students think that coordination number, ma'am, number of ligands attached. No, it is the number of donating sites that are attached to the central metal atom, right? I'll give you one more example here. Let's say if you talk about these two things, right? Chloride has one donating site, right? 6 chlorides you will have, so coordination number will be equals to 6. Ammonia has one donating site. Total you have 4 ammonia, so coordination number will be equals to 4. Till now we are talking about monodentate ligands. But what if you have those kinds of ligands which are bidentate, tridentate, then what you will do? Okay, if you have bidentate ligands, like you have, let's say, nickel, okay, I'm writing Ni, this is En twice. What is the answer? This is En twice. If you see, ma'am, coordination number is the number of ligands attached, then you will say, ma'am, coordination number is 2 because 2 ligands are attached. But coordination number is the number of donating sites, that is number of ligands multiplied by denticity. So here it has 2 En ligands, which En has bidentate, that means its denticity is 2. So here answer will be coordination is equals to 2 into 2, that is 4. Okay? Yes, students? Okay? Coordination number is equals to 4. Now, very beautiful line it is written that, ma'am, what if you have, like, do we also calculate? You are saying number of bonded sites. So, if I say this is metal, right? This is attached with double bond to some ligand. Now, are these counted as 2 sites? No. Pi bond is not counted here. Only sigma bond is counted, right? Wait a minute. What just happened? Okay. So coordination number of a centimeter is determined by only the number of sigma bonds by the ligand with the central metal atom. We do not calculate the pi bond also in this, right? Pi bonds are not counted for this purpose. Only sigma bond is called the donating site, right? Sigma bond is the donating site. Pi bond is not the donating site. Okay? Now, let's understand next thing, that is some of the atoms and their coordination number in general. Okay? This is a general table right? Mostly they have these kind of coordination numbers. Like Cu positive will have either 2 or 4. Ag positive will have 2. Au will have 2 or 4. Cu will have 2, 4 or 6. PT, PD, they will have 4. Magnesium will have 6 coordination number. This is general. Okay. Nickel will have 4 or 6. Iron 2 positive 6. Fe3 positive 6. Cobalt 2 positive is, it can have 4 or 6 both. Cobalt 3 positive is 6. PT and PD4 positive is 6. Okay. So according to different ions, your most probable coordination number we have written here. Okay. Yes. Okay. Chal. Now let's understand these two things and let's see how many of you are able to answer. And I'm waiting for your answers in the comment section, right? Ujjwal, Jayesh, William, Afrida. Then we have Afrida is saying, ma'am, when is online MV-SAT? See, online MV-SAT is on the same dates only. You just have to fill in your details there. I would advise you for offline, but rest is totally your choice. Yes. Yes, everybody. Ujjwal, Sarayana. Yes, very good. Okay. I'm waiting for your answers in the comment section. Ma'am, when is GOC? GOC, I'll start after coordination chemistry. My focus is entirely on organic chemistry, right? Next 1 to 2 months, we will only talk about organic chemistry, right? 11th, so obviously it will go on, but from 11th, I'll firstly pick GOC, then I'll teach you like full class 12th organic, okay? 3, yes. So here you are saying coordination number is 3, and here also you are saying coordination number is 3. Is it? Is it? This is bidentate. Bidentate. This is also bidentate. This is also bidentate. Tell me one thing. It is bidentate. That means one molecule is having 2 donating sites. One molecule is having 2 donating sites. So 3 molecule will have 6 donating sites. So we can say coordination number is 6. Coordination number is 6. Right? Number of donating sites. Again, one molecule is giving 2 donating sites. 3 molecules will be giving 6 donating sites. So coordination number is going to be 6 here as well. Right? Very good. No, it's 6 ambidentate ligand. No, they are not ambidentate ligand. Ambidentate ligand, bacha, ambidentate ligand like you have NO2, where nitrogen and oxygen both can donate, but at one point only one is donating. Ambidentate ligands are unidentate ligands. Ambidentate ligands have 2 donating sites, but at one point only one is donating. I will give you this simple example here. See, if you talk about, let's talk about, you are doing charity, okay? So you are doing charity. So when you're doing charity, you are giving money to 2 organizations. One is, let's say, cancer patients. Other is, let's say, old people, right? You're giving 2 charities, right? So either ambidentate is, which is giving same person who has 2 donating sides. It is donating to 2 by 2 sides. It is donating to 2 sides, right? But from January to July, he is donating to cancer patient. From August till December, he is donating to old age home, right? This is ambidentate. He is donating to two sites only, right? It has two donating sites, but at one point, only one donation is happening. Now, someone is out there who is from Jan till December, they are donating to both cancer and both old age home, right? That is called, at one point, you are donating through two sites. That is called bidentate ligand. Okay, that is a difference in ambidentate and bidentate. And these are bidentate ligands, so that's why coordination number is 6. Okay, right? Clear? Clear, everybody? Right? Now, let's talk about coordination sphere. Coordination sphere consists of center metal ion, ligands attached and enclosed in square brackets, is collectively termed as coordination sphere or coordination entity, right? The ionizable group are written outside and these are called counter ions. Okay, I'll take some example here. Let's take Fe, this only. Fe C2O4 3. This is 3 negative, no? So you can say K3 this. Now, firstly, just understand that if this kind of complex is given to you, what is what? Here you will say central metal atom is iron. Ligand is oxalato. That is C2O4, right? Which is bidentate. Counter ion. These two things are inside the bracket, as you can see. Counter ion will be outside the bracket, right? And this is nothing but K positive, right? Now I'll tell you how to actually dissociate this thing. So this example they are taking, right? I'll just tell you another example. You have K4FeCN6. Now, if you add water, if you dissociate this coordination complex, as I told you yesterday in the last class, that whatever is inside the bracket will not be dissociated, right? So it will be K positive because potassium exists in positive. If this is 4, see, do you know the funda of cross multiplication, right? If I have Al3 positive, you have SO4 2 negative. It will, this is 3 positive, this is 2. It will cross multiply and it will be Al2 SO4 thrice. That means you have cation, you have anion. By cross multiplication, you will have a compound. Okay. So that means if here, let's talk about this only. If I want to dissociate it, how will I do it? The thing that is written here, it will be over here, that is SO4 2 negative. The thing that is written here, it will be over here, that is Al3 positive. Here you have 2 of Al, so you add 2, 3 of SO4, add 3. That's how it is written. Okay, so that I showed you a simple salt, right? Now I'll be showing you coordination compound, how to dissociate, right? This is 4, this is 4, that means this 4 must have been here, right? This is 1, that means this 1 must have been here. That means it is K positive plus FeCN6, 4 negative, 4 negative. How much K you have? 4K you have. So you will write 4K positive, right? Now, how many ions after dissociation it is giving you? 5 ions. It is not dissociating Fe or Cn because it's a complex compound. Okay, so that's how we write it, right? So here the counter ion is this one. This is the counter ion. This is center metal atom. This is the ligand. Okay, everybody. Now let's talk about coordination polyhedron. Right. So we know that there is a metal and ligands are donating the electrons. So it can exist in different structures, geometrical structures, right? So that is called coordination polyhedron, right? Spatial arrangement of ligand atoms which are directly attached to the central metal atom defines the coordination polyhedron. We will talk about this geometries more detail in VBT, CFT and isomerism. Okay? Okay guys? Sure. Now, can you see the different diagrams here? Can you see the different diagrams here? This is a metal that is surrounded by 6 ligands in an octahedral geometry. Now, do you want to see this octahedral geometry? Where it is? Just give me a second. I'll just show you how does it look like. Wait a minute. 2, 3, 4, 5. Okay. So, this is one ammonia, first ammonia. This is the second ammonia. Can you see this? This is how it is looking. Now, I'll be putting rest of the atoms here. Right? It's like a square planar. Right? Then, 2 more. One is over here, other is over here. This is called an octahedral geometry. Okay, this is called Happy Independence Day. This is called an octahedral geometry. Right? Now, if you see this particular thing, these two atoms are perpendicular to these two sets and these two sets. Similarly, these two atoms are perpendicular to all the other atoms. Okay, so they all have 90-degree angle. Can you see? 90-degree angle all of them have, right? So that is called our octahedron. Actually, it looks like this. Okay, actually it looks like this. There is a square planar, right? Square planar geometry. Can you see this over here? This is square planar. Okay, this is square planar, right? Two opposite, all are at 90-degree. If you add 2 more into this, that will become octahedral, right? So this is the arrangement in which they can be, right? One is octahedral geometry, then there is square planar geometry. As you can see, this is square planar geometry, right? So these are the geometries where it can be in. Now, yes, definitely you can join. Now I'll be showing you one tetrahedral. Now we have one tetrahedral also. 1, 2, 3, and this is 4. Okay. 1. Then you have this 2. Yes. Now, not tetrahedron, usually we think something else, but in reality, it doesn't look like this. Okay? We draw it like this, but how does this tetrahedron looks like? Okay? This is how it looks like. You will have this one atom, which is always at 1. This angle is 104 degree. Okay? 28 minutes. That is the angle. This angle is also same, this angle is also same. You will say, ma'am, it does not look like that all the angles are same. Let's focus here. If I put this here, same thing you are getting. If I put this here, same thing you are getting. If I put this here, same thing. put this here, same thing. I put this here, same thing. So can you see, if we are getting the same image by having any one of them on this upper position, that means its angle is same, and that angle is called 104 degree 28 minutes, right? Okay, clear? Clear, bacha? Done, 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 done. Done, 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 done. Tell me, any problem till here? Any problem till here? Are you able to visualize what is these polyhedrons? Because when you are going to study CFT, VBT, isomerism, most like difficult part of this chapter, isomerism. Because in isomerism, you need to visualize these structures. And I'll teach you in a 3D way only. I'll make the structures and then only I'll teach you. Okay? Whew. So this is octahedral, tetrahedral. Now this explanation, you already know that why it is looking like this. Okay, you already know, right? These two are straight, so that's why with solid lines. This is, if I say this is forward, so that's why this is represented by a solid wedge. These two are backward, so that's why these two are backwards. So that's why they are represented as dash wedge. Okay. Now you know why it is represented like this. Similarly here, this one, this tetrahedron. If I say these two, right? If I say these two are on the same plane. Let's say I have put these two in the same plane. Can you see? These two are on the same plane. Can you, if it's like this, then it's not the same plane. These two, I have put it in the same plane. Let's say this is that plane. Let's say this hand is that plane. Now one will be forward, one will be backward. One forward, one backward. Okay. So that's why we have these two as solid, and this one is backward, this is forward. Right? Okay. Yes. Now let's talk about next, that is square planar, as I have already told you. Other is trigonal bipyramidal. So we are going to go through these things in detail, but for the time being now, because when I'll start chemical bonding, then I'll teach you all of this, but that's the 11th section. Okay, we will do in 11th class, right? That also I'll take the classes for that, right? But as of now, I'll just tell you what is trigonal bipyramidal. Okay, how does it look like? This is a triangle. This is a triangle. Can you see triangle? Can you see that? Right? Triangle. Now, two pyramids. If I put one, it will form a pyramidal structure, right? If I put one here, it will form a second pyramid over here, right? So, one pyramid, second pyramid. One pyramid and second pyramid. So, trigonal bipyramid. Okay, that's why it is called as trigonal bipyramidal. Square pyramidal, I have already shown you, right? But now, if you want, I'll again show you that. Square pyramidal. For that, you firstly draw a square planar, right? This is the square planar. Now, put one pyramid. This is the pyramid. So, square pyramidal. And if you say, but what is square bipyramidal? Right? Square bipyramidal. This is octahedral only. Right? Yes. Beta, this is not chemical bonding going on. Right? I'll teach you that in chemical bonding. And the hybridization of coordination compound is there in VBT theory. That will be in the next lecture. Now, let's talk about oxidation number, right? How to calculate that. So, oxidation number of sentimental aluminum complex is defined as charge it would carry if all the ligands are removed along with the electron pairs that are shared with the center metal atom. Basically, you just have to find the charge on the center metal atom, right? It is represented by Roman numerals like this 1, 2, 3. When we will do nomenclature, in nomenclature, oxidation number is represented as Roman numeral. Okay. Now, this is not a theoretical concept, so I'll teach you this, how to calculate oxidation number, right? This is the compound. You will take center metal atom as X. How do you calculate? X. CN is a monodentate ligand having -1 charge. Okay. So charges you should know. That also I'll give you a table where you would know the charges. Okay. This you have to learn. Like CN has -1 charge. Water and ethylene diamine are neutral ligands. Chloride has -1 charge. Oxalate has -2 charge. This you have to learn. Okay. And without learning this, VBT, CFT, nothing you will be able to understand, right? So X minus, this is plus you can add, plus -1 is charge of 1 CN and 4 CN you have here equals to -3. So it will be X minus 4 is equals to -3. So X is equals to +1. So copper has +1 oxidation state, and that's how we write it. That's how we write it. Next, let's talk about homolyptic and heterolyptic atoms. Right? What is homolyptic? Where only one type of ligands are there. So all the ligands are of ammonia, so it is homolyptic. And a question on homolyptic, heterolyptic, they have asked in 2024 or 25 JEE. Right? So it's important. Heterolyptic is when more than one kind of ligands you have. So here you have ammonia and chlorine both. So it is heterolyptic. Right? Okay. Now, let's see this question here. JEE 2025 question. Okay. Here the concept of oxidation and homolyptic, heterolyptic, both we will apply. Let's see. Identify the homolyptic compounds with odd number of d electrons in the central metal atom. 3-4 things you have to do here, right? Firstly, I would ask you to calculate which of the following are homolyptic, which are heterolyptic. Okay, firstly, write it down. This is homolyptic. Okay, homolyptic. This is homolyptic. This is heterolyptic. 2 ligands it has. This is homolyptic, only one kind of ligand. This is heterolyptic. See, heterolyptic are out of the equation because they are asking homolyptic. So this to already went gone. This is already went gone. Now you have to check for A, B and D. Let's calculate the oxidation number. Oxidation number of this will be X minus 8 because oxygen has -2 charge. This we have discussed in redox reactions as well. Okay, -2, so X is equals to 6. Right? This one is having X minus 6 is equals to -3. So X is equals to 3. Right? And this one is having X minus 4 is equals to -2. So X is equals to 2. So we have discussed for these two and this. Right? That means here you have iron 6 positive. Right? Here you have iron 3 positive. Yes. Here you have cobalt 2 positive. See, iron is nothing but it is 4s2 3d6. This we have discussed in DNF block as well, right? So you take out 6 electrons, it will be 4s2 3d0. This will be, you take out 3 electrons, 4s2 3d3. This you take out 2 electrons, this will be, cobalt is nothing but 4s2 3d7. You take out 2 electrons, it will become 4s2 3d5. Now tell me, you need to have odd number of d electrons. Where you have odd number? Happy Janmashtami, Happy Janmashtami. Okay, so here you have 3d0, 3d3, 3d5. This is odd, this is odd. So answer will be B and D. Okay, everyone? Tell me. Any problem? Any problem? Any problem? Any problem? D. Okay? B and D is the correct answer. Okay? Tell me, students, if any problem is there, do let me know. Okay, B and D is the correct answer. Will you be able to solve it if they ask you the same question in the exam? Will you be able to answer it or no? Now we'll jump to the next section also, right? Okay. Yes. Ma'am, first we take electrons from 4s. No, ma'am. Wait a minute. Yes. 1, 2. So sorry. I'm so sorry. Let me see. You take 6 electrons, 1, 2, 4. So it will be 3d. 4, 2. This will be, you take out 3 electrons, 1, 2, 3. So it will be 3d5. I'm so sorry. You need to take the electrons from 4s first. Yes. By mistake, I did it. Right, cobalt is 4s2, 3d7, take out 2 electrons, so it will be 3d7. Again, we are getting the same answer, that is B and D. Okay, right? Any confusion? Very good, Supriya, very good. So, now we will talk about nomenclature. Now, how many of you find nomenclature easy or tough? Is nomenclature easy? Or ma'am, it's very tough? Do you find it easy or tough? Wait a minute. My throat is literally so dry right now. No? Okay. How many of you love nomenclature? You find it easy? You find it tough? What you feel, right? Because only then I'll see that what kind of level should I take for nomenclature. You find it easy, you find it moderate, you find it really tough, do let me know in the chat box. So let's talk about nomenclature, right? Just like in organic chemistry, you name the compound according to certain rules. Similarly, for coordination complex, which is also a different kind of altogether a different subject itself, it can have like coordination compounds because it's so much in variety, right? So these coordination compounds, right, they have their own rules of writing the formula and writing the nomenclature, right? So firstly, I'll talk about writing the formula, but before that, these are few things that you should know. how do you name the ligands? Okay. So, first thing is all the negative ligands will end with O or ido. That's why you have chlorido, bromido, oxalato, then iodido, right? Why you have OOA here? Because that is in the rule, right? So when you see these ligands here, these are the negative -1 ligand. All of they have -1 charge, right? I told you now these charts are very important. So when we discuss that, let's say you have, wait a minute, let's say you have NO2, right? Let's say you have CO, NO2, OH, H2O3. Okay. Now tell, let's say this is something, let's say +2. Now how do you write it? Just take an imaginary compound I have taken. Okay. So this will be X. NO2 falls into the category of -1. So NO2 is -1. Then you have hydroxy, that is -1. Water is neutral, zero charge it will have, right? So how do you write it? X minus, because 1 will have -2, so 2 will have -2. 1 will have -1. This will have 0. So it will be -2 -1 plus 0 is equals to +2. And here x will be equals to +4. Right? That's how you use the, whether it's a neutral ligand, it's -1, it's -2, directly from the table you will use it. So this table mark it very, very important, right? So ammonia, water, carbon monoxide, pyridine, all these are neutral ligands, okay? These are -1 ligands, their charge is -1. Right? Talking about this, pyridine, ethylene, diamine, neutral ligands. -2 ligands are, acha, if you see all of these are monodentate. These are the monodentate ligands. If you talk about all of these, they will have denticity 1. They have only one donating site. Understood? They all have only one donating site. These are bidentate ligands which has two donating sites, out of which bipyridine and ethylene diamine are neutral, and carbonate, oxide, oxalate, sulfate, these are -2. Right? Now, can you see the names here? Can you see the names here? Can you see the names? Neutral ligand has the same name. Ammonia is amine. Ammonia is amine. Water is aqua. Very important this is. Water is aqua. Carbon monoxide is called as carbonyl ligand. These are the names that you will use. This is the name of the compound or ion. But in coordination chemistry, we are going to use these names. Okay. Then pyridine is the same, that is pyridine. Okay. CO, carbonyl. Then you have H2O, aqua. Amine, ammonia will turn into amine with double M. Okay. Here you have double M. Right. This is very important that it has double M here. Here it has double M. So this is important. This is important. All of them are very important. Now azide will become I. Now all the negative ligands have O or ido. So that's why you will see all of them will have azido, bromido, chlorido, cyanido, fluorido, hydroxodo. Right? So O you have to put there. Nitrito. Now can you see why we had two names? These are ambidentate. These are Ambidentate. That's why ambidentate means here when nitrogen is donating, it is called nitrite to N. When oxygen is donating, here nitrogen is donating, here oxygen is donating. It is called nitro to O. SCN is thiocyanato. If it is donating from nitrogen, it is called N. If it is donating from sulfur, it is called S. Okay? Understood? Yes. Is the table clear? These are all monodentate, and about bidentate, bipyridine is called bipyridine only. Ethylene diamine is called ethane 1,2-diamine. Okay? Ethane 1,2-diamine. Carbonate is called carbonato, oxido, oxalato, very important. This is a very, very important ligand. Then sulfato. Okay. Negative ligands will always have O or ido. This is very important. Right. Now let's talk about this is like another sheet, right? Which is for you guys, just the names. Okay. Names of all the ligands I have written here, all the ligands, right? You can just go through this, right? All the ligands. These are some cationic ligands, right? Which have +1 charge. They have +1 charge. Okay. If you want to, if you're preparing for JEE Advanced, right? All of these ligands should be on your tips, right? If you're preparing for mains, still some will work, but for advanced, everything should be on your tips. Even for mains, also everything should be on your tips, right? Now, this is also another, this is actually was the same one only, right? Just written in a better way, okay? So, monodentate, -1 charge, bidentate nutrient, bidentate -2. This is another way of writing the same thing, okay? It is this same that is written in this way. Okay, I think this one is written better, right? So I would want to choose this one, right? So what I'll do now, you can just verify if all of them are there. I think it should be there. Okay. Now, these are the complexes. Now, here what is the counter ion and what is the coordination number that you have to take. If you see this, outside the bracket is counter ion. So this is K, Cl, Fe, and here you have NO3 outside the coordination bracket, right? Now, why it is K positive? Because it will be cross multiplication. If here you have 2, it should be -2 here because it is cation and then an ion. So it will be -2. This will be here you have 1, so it will be +1. So it is, that's why K positive. This will be, this whole bracket here is 1, so it will be -1. This is 3, so it will be +3. Okay. Here it will be 4, so it will be -4. This is 3, so it will be +3. So that's why it is iron 3 positive. Whole bracket has 1, so it will be -1. Whole, this has 2, so it will be +2. Okay. Now, if you want to write down the oxidation number for all of them, right? Writing down the oxidation number for all of them. How do you write it? Simple way, very simple way. This is X -4 because cyanide is -1. So -4 is equals to -2. So it is X is equals to +2. Oxidation number is +2. What is the coordination number of this one? Oxidation number is +2. You can say oxidation number is +2. Coordination number is what? How many ligands are attached? How many donating sites? 4. So it will be 4. Okay. Talking about this one, right? This is X plus 0 is equals to +3. Because This is a neutral ligand. En, ethyl, ethane 1,2-diamine. It is a neutral ligand. You can see this over here as well. We have written it here. It's a neutral ligand. So it will not give any charge, right? So this will be +3. Chromium oxidation state is +3. Coordination number will be what? A bidentate ligand, 3 times means 3 into 2, that is 6. This one, here you have x minus 6 is equals to -4, so x is equals to +2. So oxidation number is +2. Coordination number here will be 6, right? Last is this one, x minus 2 plus 0 is equals to +2. So x is equals to +4. Here oxidation number is +4. Coordination number will be 2 donating sites by chlorine, 4 donating sites by ethane diamine, because 1 ethane diamine will have 2 donating sites, 2 ethane diamine will have 2 into 2, 4 donating sites. So answer will be 4. Okay? Okay. Yes, everybody. Is that clear or not? Tell me. Yes, bacha, tell me if that is clear or not. Yes, Ujjwal. Then we have Puneet. Where are the other students here? Beta, watch the lectures again. What else to do? है ना? What else to do? Have to watch the lectures again, do the practice again. I don't have anything which I will give you to eat and then you will, be able to understand that. Watch the lectures throughout. Okay? Now, let's understand how to write the formulas. Right? These are some of the rules. Center metal atom is listed first. This is inside the bracket. Okay? That bracket can be positive, that bracket can be negative. Firstly, we are understanding inside that coordination entity, you will write center metal atom first. Means here you should have atom. Ligands are then listed in alphabetical orders. Here you will have ligand 1, ligand 2, ligand 3, ligand 4 in alphabetical orders, right? Like if you have ammonia, amine, and you have chlorido, then you will list it like this. Firstly, you will write amine, then you will write chlorido. Okay. Next is polydentate ligands is also listed alphabetically. In case of abbreviated ligand, the first letter of the abbreviation is used to determine the position of the ligand in the alphabetical order. First letter, like you have ethane diamine, E will define the alphabetical order, right? Then we have the formula for the entire coordination entity, whether it's charged or not. It can have overall positive charge or negative charge or no charge. Anything it can have, right? Is enclosed in square brackets, right? When ligands are polyatomic, more than one ligand will there. The formulas are enclosed in parentheses. That means this kind of parentheses, right? Ligand abbreviation are also enclosed in the parentheses. Now, what do you mean by that? For example, you have cobalt Cl3. Okay, then you have how many ligands that we have written here? Let's say ammonia you have, 3 ammonia you have, then you will have a bracket and then you will add 3. Then you will have a square bracket here. Okay, so this is what they are telling you, right? Now there should be no space in ligands, right? Ligands are written like this, L1, L2, L3, then L4. There should be no space. When the formula of the charge coordination is to be written without that of counter ion, the charge is indicated outside the bracket. For example, you have K4FPCN6. Okay. If I want to write this without the counter ion, this is the counter ion. Without counter ion, this is 4. So this is an cation, this is an ion. So this will be -4. This will be +1. So you can write it like this. Okay, you can write it like that. The charge of the cation is balanced by the charge of the anion, right? Always they will be balanced by each other. That's how we calculate the coordination number. And I'll just tell you how. These are the two examples, right? This is center metal atom. This is ligand. This is the number of ligand that is written here, right? And this whole is representing the coordination entity, and this is -3 charge, right? Similarly, this is center metal atom, this is ligand, and then you have outside the bracket you present the charge. Okay. Now naming is very important. Okay. Now we will understand naming. Cation is named first in both positively and negatively charged coordination entity, right? Cation is named first. Now, it's a very important thing, like you have NaCl. You call it sodium chloride. You don't call it chloride sodium, right? So always cation is written first. So you can have some counter ion here, and this can be your cation, this can be your anion, or opposite can also happen. You can have cation as the coordination entity, anion as the counter ion. That can also happen. Okay, that can also happen, right? But whether you have cation as counter ion or coordination entity, you will write cation first. Then ligands are named in alphabetical order before. Very important, very important. In, if you see, when we write the formula, firstly you have central metal atom, then you write ligand. But talking about this, firstly you have, very important this is, okay. Firstly you write the ligand, then you write the central metal atom, okay. This procedure is reversed from writing the formula. It is totally opposite. Name, now this point is also very important. Anionic ligands are ending with O or I. Neutral and cationic are named as it is, but aqua we write for water, and amine we write for ammonia, carbonyl we write for CO, nitrosyl we write for N. Name of the names that I have already given in the chart. Now formula of the coordination that will be written while writing the formula of the coordination entity, they are enclosed in brackets. Okay, but now if you see, you have to do prefixes. So prefixes means, let's say you have 3 ammonia or 4 ammonia or 5 ammonia or 6 ammonia. You will have to mention it. So you will mention it by di, tri, tetra, penta, hexa. Okay, these will be the names. But when the name of the ligands include a numerical prefix, for example, you have ethane diamine. In ethane diamine, in the name of the ligand itself, you have di. Now, in these kind of ligands, you will use bis, tris, tetrakis, pentakis. Okay. I know some of you will take now feeling of this name. I know what are the other jokes that you are going to spread for this one, right? So, when a name of the ligand includes a numerical prefix, then it is bis, tis, tetrakis are used as the ligand name before it. Oxidation state is written in the Roman language, Roman in the parenthesis, like you have copper 1, right? So it will be written as copper 1, copper 2, like this, in the end of the name. Very important thing is that, I'll just say, oxidation state of metal in a cation and ion or neutral state is written there. It's a very, very important point, that is this one. Very important point. Again, it's a very, very important point. It says that if the complex ion is cation, metal is named same as that we write, like copper, iron, right? We'll write it the same. But for example, Cu in the complex cation is cobalt, Pt is platinum. If the complex is anion, this is anion, then central metal atom will change its name with suffix ate. Like you have cuprate, you will have ferrate, you will have aurate, you will have argentate. Argentate is for silver. Argentate. Okay, so these will be the name that are ending with 8. The neutral complex molecule is named similar to that of complex cation. Okay. Now let's see and apply all these rules here. Beta bracket. This one. This is square bracket. Okay? Let's see. How do I write the name? Firstly, I'll see this is 3. So this will be plus 3 here and this will be minus 1. So this will be Cr NH3 3 H2O 3 plus 3 Cl negative. Okay, it is named like this. Now, if you see this here, how it is named like this. Now, if you see this here, I have to name it. Okay, so these are the things that I'll have. Firstly, I'll name the cationic part. Cationic is the coordination entity, so how will I name it? Firstly, I'll name the ligands in the alphabetical order. This is amine. This is aqua. A is same, but M and Q. So M is before Q, so alphabetical order is ammonia and then aqua. So it will be triammonia, amine, triamine. Aqua is also triaqua, right? Chromium. Now, whenever the this full entity is in cation, then this will be written as simple chromium. But if you have here negative coordination entity, that will be written, then it will be written as chromate, right? But this whole thing is cation, so it will be written as simple chromium. Now, what is the oxidation number? It is X plus 0 is equals to plus 3. So, it will be plus 3. You will write it in Roman numeral, right? After that, Your counter ion is Cl. So you don't have to write trichlorido. Just write chlorido. Just write, not even chlorido, you will write chloride. Because chlorido is when chlorine is acting as a ligand. Here it is acting as a counter ion. So you don't have to write chlorido here. Okay? It is counter ion. Counter ion. It is not a ligand. If chlorine is as ligand, then it will be written as chlorido. Another question that can happen in your mind is, ma'am, why we have not written trichlorido? Trichloride. Because if this is 3, only then, because here it is 3, that is the reason here you have plus 3. And that is the reason your chromium oxidation state is coming out to be plus 3. So that's why you don't have to mention here mention here that this is tri, because this whole thing is answering that this will be 3 chlorine atoms. Okay? Right? Huh. As a ligand, you can use chloro or chlorido, but as a counter ion, it will be chloride. Okay? So that will be the answer, as you can see here. Triamine, triaqua, chromium, 3 chloride. Next is this one. Let's see how many of you can answer this. Let's see. If you see this here, now, can you identify what kind of ligand this is? CH2, CH2, ethane 1,2-diamine. This is nothing but this is En. So I can also write it as CO En3 twice SO43. Right? Which is nothing but, if it is 3 here, that means it will be CO En3. If this is 3 here, it will be plus 3 here. If it is 2 here, it will be minus 2 here. Here you have 2 of these things and this is that. Okay. Now, what I'll do? Now, how do you write it? Now, guys, how do you write it? Everybody. Write the cation first. No answer in the chat box, ma'am. You only teach, ma'am. We are only going to do nothing here. Beta, answer something, na? It's not like by watching me doing these questions, you'll be able to do it in the exam. You have to do it yourself, right? Firstly, I will write ligand or center metal atom. Ligand, right? So it is, should I write it tri? No, I should write it tris. 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 Ethane diamine. Now, when you have a ligand that is having di, tri, tetra, and you are writing bis tris here, then this ligand will be named in parenthesis. That means bracket. So it will be tris ethane 1,2-diamine cobalt. What is the oxidation number? X plus 0 is equals to plus 3. So it will be 3. And then the counter ion, that is, and it's not sulfide, it's sulfate. Okay? That's how you write it. Okay? So, tris, this is in bracket, cobalt free sulfate, that we have done. Now, this is a very, very important question that they have asked also. This is from your NCERT only, right? 2 brackets you have, right? This is the cationic bracket. This is the anionic bracket. Problem is we don't know what should be, because it can be 1 plus 1 plus minus 1, it can be plus 2 minus 2, it can be plus 3 minus 3. So firstly, by hit and trial, you have to write it. Okay? That is, if I write Ag NH3 twice, this is positive, and I write AgCN2 minus 1. Is the oxidation number feasible? Let's see. This is x plus 0 is equals to plus 1. So Ag will exist in plus 1. This is x minus 2 is equals to minus 1. So Ag will again exist in plus 1, which is possible. Which is possible. If you put 2 and 2 here, if I put 2 here, it will become, if I put, let's say, I am copy pasting it. If I put 2 here, if I say this is plus 2, this is minus 2, then the answer would be x plus 0 is equals to plus 2, Ag plus 2, this does not exist only. X minus 2 is equals to minus 2, so x is equals to 0. Ag is 0, this is also not possible, right? In an ionic form, it will be 0 oxidation state, not possible, okay? So that's why this is eliminated and we have chosen plus 1 minus 1. Now, I'll focus on cationic part. Firstly, we will write ligand, that is triamine. When the cation part is the coordination entity is in the square bracket, this center metal atom is written simple, that is silver. Write silver, it is coming out to be 1. Then you will write cyno or cyanido, you can write both are right only. Cyno or cyanide, or cyanido also you can write. Usually cyanido you will see, okay? Dicyanido. Then you have silvatate, no, argentate. Argentate is the Latin name for silver, so that's why we write it as argentate. Whenever the coordination entity, it is negative, then the center metal atom will end by 8, okay? And that's how you have the full-fledged name. Tell me if you have any problem in this one. Okay. If you have any problem in this one, then do let me know. Diamine I have written, no? I have written triamine by mistake. It was 2-amine, no? So it should be diamine. Okay. Diamine, silver 1, dicyanido, argentate 1. Okay. So let's see this question here. JEE Mains 2024. IUPAC name of the following you have to write. Firstly, I would advise you to calculate the oxidation number. There is no use because all of them are given to be 2. Okay? I'll use it by elimination. Bromine, and this is trimethyl phosphine. So B is first, then you will have trimethyl T. Okay? So it should be dibromido first. So it is cancelled. It should be dibromo, bis. This is di, so this is also cancelled. This is bis trimethyl phosphine. This is bis bromo, this is also wrong. So answer is only this one. Okay? By elimination only you did it, right? Dibromo, 2-bromo, bis trimethyl phosphine, platinum 2. You don't have to calculate oxidation number because all of them has 2 only. So answer will be C is the correct answer. Okay, students. Now last topic of today's class, that is coordination, that is Werner's theory. First theory you have, okay, Werner's theory, what it explains. Let's understand that. Werner's theory, it said that he was actually talking about the coordination complexes. This was the first theory that was based for the coordination complexes to understand them, right? Was the first to formulate his ideas about structure of coordination compounds. Nobody was discussing about these coordination compounds, and Werner was the first person who was trying to understand the structures, right? He prepared and characterized large number of coordination compounds and studied physical chemical behavior by different techniques. So he, by framing all those things, he gave two important things. He said that every coordination compound will have two things. One is primary valency, other is secondary valency. Simple way I'll teach you. What is primary valency? That is nothing but oxidation number. In today's date, we call it oxidation state. Is it +2, +3? That is primary valency. Secondary valency is nothing but that is coordination number. Coordination number. That's it. That's it about this theory, okay? But to understand this and how questions are asked, okay? So let's take 4 test tubes. He said that we have 4 test tubes, right? Different colors it has. Okay, this is red color, green color, violet color, yellow color. Each of them have different coordination compounds. Okay. He said that in this test tube, you have 1 mole of all these compounds, right? Then you add AgNO3, excess of AgNO3 in all the test tubes. He observed that in one test tube, 3 mole of AgCl were formed. Here 2 mole, here 1 mole, and here no AgCl. Then he gave a simple theory that the amount of AgCl formed gives us AgCl formed is equals to number of Cl outside the coordination entity. Outside the coordination entity, how many Cl you will have, right? Outside the coordination entity, how many Cl you will have. Now I'll just explain you this thing here, right? Wait a minute. Okay, wait a minute. Let me just take one. Okay. So I'll explain you one by one. If I say you have a coordination compound COCl3.6NH3, COCl3.6NH3, right? It is giving you, in the experiment, it is giving you 3 mole of AgCl. Okay, it is giving you 3 mole of AgCl. Now, if it is giving you 3 mole of AgCl, how can you write it? This is cobalt. That means 3 Cl will be outside. Out of these 3 Cl, all of them are outside. So it means it will be NH36. This tells us the formula, right? Similarly, I will write for others also, right? If you have COCl3.5NH3, COCl3.5NH3. This gives you 2 mole of AgCl. This means 2 Cl are outside. This is CO. Out of 3 Cl, 2 Cl are outside, we are left with 1 Cl. I'll write it here. And this is NH3 5. This is the compound. Okay. Similarly, you will have 4 and this is giving you 1. So here you have, this is 4. Wait a minute. This is a 4 in NH3 and this is giving you 1 AgCl. Okay. Now, if you see this here, this will be CO. This is giving you 1 Cl, so that will be outside. That 1 Cl will be outside. Out of these 3 Cl, 1 Cl is outside. That means 2 will be inside. And rest of it is 4. Coordination number 6 is coming out to be constant here. Right? Thank you so much, Abhijit. Thank you. Now, last one is very important. You have same thing. Right? Can you see one thing? They both will have same thing, that they both will have formula CO, Cl2, NH3, 4 and Cl. You have, this is a very important point. Very important point. This same formula, same number of AgCl you are having. But this is of green color, this is of violet color. Same formula, but colors are different. Why? Because their geometry is different. Their isomerism is different. They are isomers of each other. And that I'll teach you in isomerism of coordination compounds. But they are different colors because of their isomers. Right? Okay. So that's it. And here we have very beautiful thing. This I already taught you how they are having these formulas, right? How all of them are having these different formulas. Here also it is having different formulas, right? Okay. And you can see this here. If you see this, how many compounds it is going to give you? How many compounds? This is going to give you 1, 3. 1:3. This is 1, this is 2, 1:2. This is 1, this is 1, 1:1. This is no dissociation because there is no counter ion. Okay? Understood? Hanji. So that's it. Now give me the answer for this question. JEE Mains 2025 question that says 1 mole of octahedral complex compound, that is, this gives 3 mole of ions on dissolution in water. That means 1 bracket and 2 counter ions. This is the thing that then only it can give 3 ions after dissociation. 1 mole of the same complex react with excess of AgNO3 and it yielded 2 mole of AgCl. That means 2 Cl are outside, right? And here it will be CO, NH3, 5 and 1 Cl. This is going to be the compound formula, right? The structure of the complex they are asking you. So answer will be A is the correct answer here. Simple. JEE 2025, I don't know how they asked this simple question here, but this was very simple, right? Then primary, secondary valencies, the definitions, you should know some important points here. In coordination compounds, metals show 2 types of linkages, primary, secondary. Primary, I told you, it is oxidation number. So it is normally ionizable, right? Satisfied by negative ions, right? It is ionizable, right? We know that how it is ionizable because it depends upon the counter ion. If here you have 2Cl, then this will be plus 2. Here you have 3Cl, it will be plus 3. So it is dependent on the negative ion. So it is balanced by the negative ion because this counter ion is justified this, and then this will be plus 2 plus 3, and according to that you will have the metal ion, the oxidation state, right? Then secondary is, it is non-ionizable, right? We'll just calculate the number of donating sites. We don't calculate it on the basis of the charge on the complex, right? That's why it is non-ionizable. They can satisfied by neutral molecules. Ligands can be neutral, anionic, cationic. The secondary valency is equal to coordination number, and it is fixed for a metal. Right? Last question of today. Solve this, everyone. Hmm. 2025. So primary and secondary valencies you have to see, okay? So if you see this here, I'll firstly talk about secondary valency, that is coordination number. This cobalt is having coordination number plus, this is having 2, 2, 4, 5, 6. Coordination number is 6. Here coordination number is 3, 6, 7, 8. 9, 2, 3. No. 2, 3, 4. Coordination number is 4. Ammonia is 2. 1 chlorine, 1 NO2. All are unidentate. This is having coordination number of 4. Though it's ambidentate, but at one point it is donating to only one side, so it is unidentate, ambidentate and unidentate. This EDTA is actually hexadentate, so here it will be 6. Okay. If nothing is mentioned about EDTA, you will say, ma'am, here -4 is not mentioned. Nothing is mentioned about EDTA, that means they are talking about hexadentate EDTA. Okay. Now, oxidation number will be, this is X plus 2. See, this will be plus 1. This will be 0. This will be -1. This will be -2. Right, if you calculate it here, it will be, for this one, it is X plus 0 minus 2 is equals to plus 1. So it is plus 3. Okay. Here it is X plus 0 minus 1. NO2 is also -1 is equals to 0. So X is equals to plus 2. Okay. This is X minus 4 is equals to -1, so X is equals to 3. So it is 3. And last one is X minus 6 is equals to -2, so X is equals to plus 4, so it is 4. Okay. EDTA is, wait a minute, hexadentate, na? Hexadentate EDTA will have EDTA -4. So it will have -4. So it will be X minus 4 is equals to -2. X minus 4. EDTA always have -4. EDTA -4. Okay. So this is nothing but this is -4. So this will be X minus 4 is equals to -2. So X is equals to plus 2. So here it is plus 2. Just do it, solve it. 6, 3. 6, 3. 6, 3 is this one. So A is 1. A is 1. Okay? Eliminated. 4, 2. 4, 2. So B is 4. B is 4. So C is the correct answer. This is 4, 3. Oxidation number is, coordination number is 4. This is 3. 4, 3, it is 2. And this is 6, 2. 6, 2. So it will be 3. So answer will be C is the correct answer. Okay, everybody. Is this question clear? That was the last question, and we are at the end of this session, right? We are at the end of this session. That is done. Okay, C is the correct answer. Now, this question is for your homework, right? Take the screenshot, do the homework in the comment section. See, my health is not at all fine. Only I know how I am teaching you, right? I still have tonsils. It's very difficult for me to even speak a single word. I cannot explain that pain, right? So if I am taking this pain for you guys, what minimum you can do is do your homework, right? Okay. So this is the homework. Take the screenshot and do it. Next is, this is another homework. Oxidation number you have to find out, right? So these two questions, right, you have to do. And before going, guys, let me just remind you again that this Freedom Festival sale is going on. Today is Independence Day, and because of that, we are giving you this Freedom sale where 79% off is there on all the Vedantu's courses, right? You will see this over here. Like I say, Sigma Express, right? That is at 1499. So, the price has really, really decreased. So that's why this is very, very important for you, right? To get this offer now itself, because 17th is the last date. After that, this will not be valid, right? Okay, chal. Okay then, students, then bye-bye. Take care. See you all in the next class. Bye-bye. And from the next class, we are going to start with VBT, right? That we will do in the next class. Okay? Okay then, bye-bye.